So thank you, students, once again for joining this informative session. This is a session on how we can build a career in data science in today's time, which is coronavirus time and COVID-19. Everywhere there's negative news. Any news channel we see, there's so much coverage on this. But there are, I always believe there are offshoots of opportunities in the most trying times. And data science is one of those fields which is really taking off, and people have come to learn and appreciate the value of data and analytics and how it can genuinely help solve a problem, whether it be a business problem or a public sector problem or a government problem, even politics. So the application of analytics is wide and varied. And slowly with advanced technologies, computing power, the availability and access to large volumes of data, and the merging of statistics and mathematics into practical life and applications, all the merging together has created many more opportunities in terms of practical applications and solving real world problems using analytics. But over the years, we have serviced a wide number of clients, and as you can see, we've satisfied over 60 plus clients, Indian clients, MNCs outside India, across the world in many different industries, including banking, financial services, insurance, telecom, aviation, retail, CPG, many sectors. In fact, what I am planning to do is to give you today a fair bit of understanding of what is the field of data science all about. Some of you are more advanced in your knowledge. Perhaps you are studying, your curriculum includes some courses and electives on data science, machine learning, AI. Some of you have heard about the buzzwords, but have actually never worked in that field, never studied about that field. So today is an opportunity for you to learn about this. I will also tell you a little bit about the practical aspects about a data science project, because that is something which is many people who are outside the industry do not know, that how does a data science project actually work. So I'll walk you through that as well. And then I'll focus a little bit on the current trends, the current scenario, of course, the kind of jobs, roles you can get, and the kind of salary packages, because of course financial compensation is also relevant and important as much as career growth and opportunities are. So we have tried to bring together some of those insights for you, and also to help you understand what are those analytics opportunities which are available now due to the change in the world, corporate world, personal world, because of the coronavirus epidemic. Sorry to say epidemic, should be a pandemic. So there are many opportunities which have come up, and many more areas of applications where analytics and AI and ML are going to be in use or are already in use. So we would like to share with you today what are those career opportunities, what are those use cases, problems that you can solve if you join the industry. And as always, how do you start? So what is the start? Where do you make that first step? So we'll also explain to you how you can prepare the first few steps in building a career in the field of data science. So here is a quick look around what exactly is data science, because we hear a lot of these buzzwords every day, these jargons, but sometimes we're not very clear exactly what does it encompass, what does it mean. So in essence, the way I see data science is it's nothing but a practical application of an amalgamation of various techniques, methodologies, practices to solve a business problem, to create an insight by analyzing some kind of data. Now, data could be in the form of structured data. Structured data could be tabular data, enterprise-generated data, system-generated data, and unstructured data in the form of video, audio, text analytics. So ultimately, what data science is trying to do is answer a question, come to a solution for a problem. And it applies various applications across different work streams. So it's a combination of mathematics and statistics, because fundamentally it is trying to solve a business problem by using concepts rooted in science. So a lot of machine learning algorithms are rooted in statistics. There are a lot of memes actually about it, that machine learning is nothing but the beautiful and the savvy version of statistics. To some extent it's true, but it's much beyond that. We start going into the territory of advanced computing by setting up the right infrastructure. Once you have the right kind of data to solve the problem, you also have to have the right computing power to be able to analyze that data. So there are now advanced computing techniques available. There are opportunities to work on cloud, on premises as well. So big data can also be integrated very easily. It's not that big data was not getting captured earlier, but it was just not possible to analyze that data in such a large extent and to be able to use it to actually solve business problems. So big data companies were capturing big data earlier, but they were not able to analyze it because of lack of computing power. Some of that problem has now since been resolved. Ultimately, what you are trying to do is solve the need of a business head. You're trying to help a marketing manager from understanding what kind of offers to send to his customer so that he minimizes his cost of his campaign. At the same time, he maximizes customer conversion. Or for example, you're trying to answer the question for a risk head, a risk head at a bank, that here are the reasons why fraudulent transactions are happening. These are the kind of fraudulent transactions, and this is how you can take a corrective action. So ultimately, you're trying to solve a business problem. So you have to have some level of domain expertise to be able to solve that business problem. Apart from that, you need to have a little bit of understanding on how to present your insights. So it's not just about solving a business problem. It's also about being able to communicate with your peer group, communicate with the business head who is the intended user of your analytics. So analytics, if it is not followed through with the practical aspects and implementation, it ends up being a theoretical exercise. So it's very important that whatever analytical insights are getting generated, they are being used by the business heads to actually take corrective actions. So a quick example for this would be, in today's time, when the lockdown started, businesses such as restaurant industry, hotel industries, there was zero revenue suddenly. Day one of lockdown, there was zero revenue. In such a situation, when you have zero revenue, but you have expenses, your expenses are, you have your rentals to pay, your employee salaries to pay. How do you make sure that your customer segment is engaged so that when they are able to come back and start ordering, they choose to come back to you and not go to your competition? So there was a lot of analytics which was happening even during lockdown time from the industry to make sure how they can better communicate about the safety procedures they are taking, what kind of process changes they have done in their environment, in their offline stores, and also adoption of digitization. So some of our clients were still heavily reliant on offline business growth. When I mean offline, brick and mortar. But because of the lockdown, a lot of their business models have changed, the customer behavior has changed, and there's a marked change in the behavior of customers moving towards digital channels for consumption, whether it be for ordering in for food or ordering products from Amazon, Flipkart, etc. So a lot of businesses had to move towards digitization as well in order to be enabling these processes for customers and ensuring that the customers are retained with them. So a lot of data engineering work eventually happened because much more data is now getting collected about those customers. How can we use that data readily to analyze new customer behaviors and integrate some of that into our models? So very quick examples, there are certain groundbreaking events which happen in life, like demonetization happened now, lockdown has happened. So some of the historical ways of doing business, whether it was rule-based engines or whether it was even to some extent statistical models, the variables that we had thought of, the behaviors we had thought of customers have actually become redundant, and we had to think of new variables, new ways of understanding the customer so that we can anticipate the changes in the customer behaviors and manage our programs accordingly. So data science is, in theory, solving a business problem by using data, technology, mathematics, statistics, a scientific way of doing it, and of course, ultimately trying to solve a business problem. So applying domain knowledge, that is most important. So one of the questions we are asked is, what is a typical journey that a company takes when it is trying to apply data science? So initially, the company starts by understanding what has happened. I'm sure some of you have seen this particular diagram or an iteration thereof, but fundamentally it's important to understand what is the journey that typically a company takes. When companies are starting the adoption of analytics, they typically start by understanding what exactly is happening in my business. So the questions we are trying to answer for them is, What is my daily sales like? How many orders could we fulfill? How many customers abandon their carts if we are talking about, let's say, an e-commerce company? So how many customers did not fulfill their orders? So we're trying to answer the now, what happened right now. Then we move towards more diagnostic analytics, which is where we are trying to find the causal impacts of what actually led to this particular event. So we are trying to explain to the client that these are particularly the reasons because of which this has this action has actually occurred. So we do more of a root cause analysis. We try to understand what has happened and why it has happened. We do some kind of testing here by building certain scenarios as well to be able to answer the questions. But this is again not fundamentally advanced analytics. We start moving into advanced analytics territory when we start thinking and anticipating the future course of action. So that's where we start moving towards the territory of predictive analytics. Here, there are multiple types of questions that typically the industry will ask. So if you talk to a retail client, a company which is in the business of selling merchandise, whether online or offline, their questions may be, can you help me understand what would be the anticipated sales of this particular product in the next 30 days? That could be one question from a certain type of a company. Another company, let's say we talk about a telecom company, they may be concerned more about customer retention. So their question may be, can you help me predict how many customers and which customers are at risk of churning from my network, so that I can take proactive actions and ensure that I am able to retain them. Retention is the most difficult business decision, and even tougher than this is reactivation or winning back the customers. So that fundamentally it is much more costly to acquire a new customer as it is to retain an existing customer. And if you retain an existing customer and delight him, there's a higher chance that you can earn new business through him through referrals. So it is very critical for clients to understand how to retain customers. And that step comes first by understanding which customer is at risk. And this is where the predictive analytics techniques help to answer the question. Once we have, kind of understood this is how the business impact is happening, then we start getting into prescriptive solutions and advisories that this is how you can optimize your operations. So once you have identified which customers are at risk, how do you optimize your entire campaign strategy so that with the least amount of dollar spent, you are able to maximize customer retention? So you move towards the territory of optimization and improving the actions that ultimately the business manager will take. And then we move into other territories where we start analyzing more complex data, more unstructured data like video, voice, image analytics, to be able to think of futuristic scenarios. Fundamentally, AI is nothing but trying to interpret and mimic a human behavior. So building in those critical learning skills, critical reasoning skills, learning from mistakes, avoiding repetition of mistakes, and fundamentally assessing new situations. So AI is that part of the world of data science where it moves towards more cognitive areas and cognitive learning techniques, where typically it's trying to mimic a human behavior. And those are more advanced applications. Some of the industry applications which I can think of here are things like chatbots. So in chatbots, you are predicting what the person is intending to ask before he has even completed his sentence, so that you can reply with a certain level of accuracy that this is the question which he is asking and this should be the answer. So that is one type of AI application. Another AI application is anomaly detection. So if you're talking about factory assembly lines, and you're looking at automotive companies which are creating cars on the factory floors, it's very important to be able to analyze anomalies at the factory floor. So due to vibrations in a machine, due to high or fluctuating temperatures or humidity controls, what can be the impact on the production line? So analyzing those cues on a real-time basis and churning out the insights so that the shop floor supervisors can take corrective actions. So those could be more complicated applications of AI and machine learning. No, these are just a snippet of some of the objectives which typically a data-driven decision making, can be solved. Of course, fundamentally, we are trying to help our business managers take more informed decisions, moving away from intuitive or historical behaviors. Fundamentally, data science helps companies to be more experimental and move away from the comfort zone. So, the attitude that, yeah, this has always worked, so it will work again. We are trying the industry to move away from this philosophy into understanding how the situation is working on the real world. So there are other use cases as well. There are some examples here. We can help our clients, for example, to understand the share of wallet. So for any particular spend, whether it be restaurant, hotel, travel, bank products, we all have a finite amount of money to spend and a finite amount of time to give to our service providers, right? So fundamentally, clients try to understand, industry is trying to understand what is my share of wallet. So if a customer is spending 100 rupees on the service of travel, how much of that percentage of that travel is he actually spending through my business, and how much more I can earn from him? So we try to help answer such questions. In the banking and lending business, we are trying to help clients mitigate risk. So when we talk about risk mitigation, we are helping them predict the kind of anomalies in customer behaviors. We are able to help them identify fraudulent transactions on a real-time basis, so they can protect their capital and also reduce their claims. Customer retention, we've already talked about, campaign ROI as well, so I'll skip through some of those. And customer satisfaction is always important. So fundamentally, we all want to be delighted by our service provider, whether it be a bank or it be our e-commerce platform. We want our vendors and our service providers to know what we want in advance, so that accordingly they provide the service to us. So ultimately, you're looking at delighting the customers, improving the net promoter scores, and getting referral business. Like I said, it's much more relevant to get referral business from your delighted customers as compared to chasing new sets of customers who have no orientation of your business and who may or may not want to give business to you. So fundamentally, it's very important to satisfy your existing customers. And some of the personalization through hyper-personalization engines, recommendation engines, that is what companies are trying to solve. So if you talk about e-commerce, Amazon is a very, very good example. It has built recommendation engines. One of the purposes, of course, to maximize customer lifetime value by ensuring customers come back and spend with them, but also to make relevant recommendations so that the customer does not spend too much time searching for a product, and he already knows he already gets a ready reckoner of comparative products available with him. So it's one way of delighting the customers while also ensuring maximum business for Amazon. So this is a more of a theoretical slide, but it helps you to understand how data has grown over the years. I skipped through some of these slides. This is available on the internet. Fundamentally, with availability of computing power increasing phenomenally and the availability of data, we have been able to use data effectively in the industry. And this is what this slide is trying to, convey. How has data science evolved over the years? So this is a slide which is, trying to capture that for you. Initially, with IBM mainframes launching sometime in 1950s and all, fair bit of computation had started, but the applications in real world were very, very limited. It was very costly to acquire mainframes and have them work on business problems. So typically they were being used by NASA and all for helping them crunch numbers for getting the rockets to moons. But it formally analytics and data crunching and data mining got into business when ERP products were launched, and companies had a way to capture data and store with them, even if they were being stored in silos, and each function had its own data visibility. And that's how the business has moved. Eventually, with, like I said, availability of high computing power and the ability to be able to store and analyze big data, that is where the journey has now taken. And actually, the graph has even accelerated beyond this. So this is a graph till 2010s, but now we are talking more about AI and machine learning and our artificial intelligence to seep into everything that we do in life. So it's been an accelerated curve for the industry. And very quickly, of course, we need not be learning too much statistics here, but there are actually certain measurable business impacts for businesses when they apply AI and machine learning. There was a study done recently from Forbes, and they found from the business heads that using AI and machine learning, companies have been able to accelerate insights generation by 60%, increase the productivity by 59%, and they have done also a cost benefit analysis and been able to accelerate savings by adopting AI and machine learning. This is another example from the world of finance. So Capital One is one of the largest banks in the US, and it's a fairly young bank. It started in the 90s, and as compared to some of its larger peers, it decided to go with an analytics first approach. So it is one of the few companies, apart from companies like American Express and Bank of America, which adopted analytics and machine learning very early in their careers, in their industries. So the fundamental problem that they were trying to solve was, how do we make sure we are targeting the right product to the right customer at the right time, the right price, using the right channel. And they fundamentally adopted analytics across the organization, right from marketing to customer retention, operations, risk, fraud control units, everywhere, wherever they could possibly capture data about the customer, integrating third-party data, integrating syndicated data to improve and enrich the profile of customers that they already had. And then they built a lot of predictive models. And fundamentally, they have been able to increase customer retention by 87%. They've been able to reduce their cost of acquiring customers by 83% by identifying junk customers and only chasing those leads which had a high propensity to convert. And then ultimately, they've been able to increase their share of the market from 3% to 7.2%. So that's an excellent example of how companies have ingrained analytics into business and been able to benefit from that. I'll quickly take you through a data science project. So fundamentally, we start from identifying a business problem and understanding what is the context of a business problem. We have to interact with stakeholders. If you're an in-house analytics team, you ultimately have to create a use case around this. You have to create a case study for the business heads to sign off with. You have to identify the relevant internal and external data which is available with you to create your big data lakes and create your curated analytics data marts from which you can work on specific business problems. Ultimately, what you're trying to do is to solve a business problem. So you have to create a framework for an analytics-based solution. And then once you have applied the analytics solutions, you would like to share your insights and findings with the team and adoption of those analytics into business operations. Very quickly, these are the quick examples of data points that can be used for different kind of problem areas. So when we talk about operations, an airline has very different kind of operation as compared to financial services or a telecom or a healthcare company. So I'll just focus on one segment here. So in airline, ultimately you're looking at optimizing your network. Where should I fly next? Which segment is giving me more revenue? Which segment I should stop? Which segment am I required because of the government's regulatory requirements to run my business even if it's not making money? So these are fundamental questions which we are trying to do. Then also small tactical problems you will try to solve for them, which is, how do I optimize the number of meals that I carry on board so that I do not waste food? So there are many different data points available for that. In telecom, I gave an example of customer churn. You can also think in telecom in terms of cross-selling. So if I want to identify which particular customer should I target for a value-added service, then how do I create those cross-sell or upsell predictive models? So many different data points are available in your everyday enterprise data, which you can then further enrich with syndicated data. Now, this is where we'll spend a minute here, and this is an actual example of how a machine learning problem is thought of and approached. So fundamentally, what we are trying to do is integrate all the different data about a customer, his transactional history, any non-traditional data that you have about him, any behavioral data. Let's say he or she is calling your call center a number of times and he is unhappy with the resolution which he has been provided. So those are signals to capture and analyze, even if it's in an unstructured format. Apart from that, many times companies, especially especially in the lending business in India, they want to integrate third-party data like credit bureau scores. So we have 4 credit bureaus in India from which we can get the credit assessment and profiles of individuals and SMEs and corporates as well. That helps the companies to build richer profiles of their customers and also better assess the risk. So this is just as an example. We will be integrating all of that data. This is where the data engineers come into play. They help create those customer 360 models. And fundamentally, after the data has been captured at the customer level, that's where we get into analytics exercises. Of course, the first step to do is to segment and profile customers. There are segmentation techniques, clustering techniques in analytics which are available. You will apply some of that. Once you have built customer segments and segregated how this segment is different from the other segment, then you move into segment specific strategies. The kind of analytics that you will do and the kind of actions you will take on one segment will be very different from the kind you will take for the other segment, because the customer behaviors are different, the customer segments themselves are different. This is where the application of predictive analytics comes into play. So these are just some examples we have kept here. We are talking from a banking financial service perspective, but the use cases may differ for retail, for telecom, for aviation. Some of the fundamental problems that clients in banking and lending business ask us is, can you help us predict fraudulent customers? Can you help us identify which of my existing customer I should target for cross-sell, upsell? Can you help us identify which customer I should target for retention? Can you help us identify which of my delinquent customer, basically a customer who has refused or is unable to pay, which customer I should target for collections? So those are some of the questions which clients ask. We build models. There is a certain technique of building these models. It takes some amount of time. The models are fine-tuned. The entire process can take anywhere from 1 month to 2 months. And then the model outputs are integrated into visualization platforms and campaign management platforms so that their business teams can act upon it. Because like I said earlier, analytics without follow-up implementation is nothing but a theoretical exercise. This is just as a quick example in the world of lending. Companies use analytics, for example, to reduce their acquisition costs, to better make recommendations of products. They also, whenever there is a paucity of data, they have to think innovatively, think of new variables to better assess credit profile of customers. Companies are using natural language processing to improve the understanding of the volumes of data that they are generating. This is an example for a company which used NLP to process legal documents and extract relevant data from that. And this is an example of American Express. It uses machine learning to understand and process thousands and millions of transactions in milliseconds so that they can identify fraudulent transactions on a timely basis. This is an example for TD Bank, again a North American bank, where they were trying to analyze customers' transactions and service interaction history. That was just as an example of the kind of the life cycle of a project. But what are the different types of problems that you can solve for, let's say, a bank or a lending company? So this is an example very quickly again of the kind of use cases you can be solving for a bank, right from customer acquisition, which customer will apply, which customer to approve, to enriching the data about the customer. Once he has acquired, then what kind of products to sell to him further so that he retains with you and doesn't go to the other banks. Let's say he started a journey using through a saving bank account. Can I cross-sell him a credit card, or should I go with an investment advisory to him? It moves from an individual to a collective whole group of peoples. We can look at portfolio analytics and analyze the risk profiles of entire customer portfolios. Moving back to an individual, we can look at delinquency and customer defaults. So when delinquency is when a customer has taken a loan, whether it be a secured loan like a home loan or an unsecured loan like a personal loan or a credit card loan, and he refuses to or is unable to pay. Can we identify such customers in advance so that we can improve our collection? And ultimately, because of data decay, a lot of times contactability is an issue. What can companies do to improve contactability of their customers? So this is an entire cycle of analytics use cases just for one industry, which is banking and lending. So several such use cases and different use cases are possible for other industries. Now, this is an interesting slide, and I'm sure all of you would be delighted to look at this. This is a very positive number, despite the chaotic times that we are in. So, globally, there's a dearth of talent in data science, and jobs are available, but people are not. Even in India, there's an anticipation that over a lakh of job opportunities are open and available for data scientists, and these are fundamentally positions for freshers who are just starting their careers. So between up to 0 to 5 years of experience, that's about 60% of such jobs. And the industry itself is growing at a healthy rate of 33%. So rest assured, this industry is not going anywhere. Although technically we are not termed as an industry, and that is our unfortunate case, but we are hoping that eventually analytics will be recognized as an industry. And long term, even from 4 years, 5 years away from now, all the job interviews, even if somebody is going for an HR profile, they will have to be able to understand the concepts of machine learning, because they will use the outputs of analytics in their day-to-day life. So some orientation to the field of analytics, AI, data science, machine learning is important so that people can work effectively. And of course, while the market is expecting India to be a leader in this field by 2022, I think we're already up there. I personally feel that India is far leading in terms of analytics use cases as compared to other countries, except for perhaps North America and some of the more evolved countries. So this is again a quick rundown on the kind of profiles which are available in this field. From a basic data analyst profile who is fundamentally collecting and analyzing data, you can move into a role of a data engineer where you're helping to better extract the data, transform it, load it into the systems, and enable the data scientist to actually work on that. And then ultimately a data scientist role, which is an amalgamation of business, mathematics, statistics. Fundamentally, you are answering business problems. You're working together with the business teams to help them how to use analytics to solve a business problem. Now, again, this is a slide which I'm sure will delight some of you. Take a screenshot if you would like to. This is relevant. This industry is high paying, very quick learning and growth opportunities are available for the right profile. And for people who are moving in the role of a data scientist, this is your ticket to get back into the functional head's role as well. So if you are working as a data scientist, you are very closely involved with the business, with the functions like marketing, operations, risk. So as you move forward in your career, you can transition back into a functional role as well. So right from students who are graduating to middle management to even senior management, there are very high growth opportunities and accelerated growth curves. If you work on projects which are giving direct ROI to business, that's one of the sure ticket ways for you to get into a high trajectory growth in this business. So pick a project which is solvable, pick a project which has business impact, and pick a project where you can learn new things as well as help somebody really solve a business problem. So it should not be a theoretical exercise. It should be a project which actually helps bring a business impact. Now, this is a slide where we wanted to talk a little bit about the impact across sectors because of coronavirus. One good thing, fortunately for many of us, is that the industry that we are talking about, data science, AI, machine learning, it kind of gets lumped together with IT, or that's the interpretation of the industry. To some extent, the jobs here and the roles here are still safe. While some core industries like manufacturing and retail and trade are heavily impacted because of the lockdowns and all, because we are working with data, we need not be physically constrained to work in a certain situation or a place. So those jobs are still continuing. I gave an example of a restaurant chain, another hotel chain, for example, with zero revenue and zero bookings in the lockdown period. They were working, their analytics team were working furiously to help their digital platform teams figure out what they can do to improve advanced bookings using analytics. So they identified those customer segments that they knew are going to start traveling as soon as lockdown gets over, and identified certain segments for the digital platform team in advance so that they can create more targeted programs and outreach programs. So analytics teams work even if there is a lockdown. For us it really doesn't matter. For us it's business as usual. It's just that we don't go to the office anymore. We work from the comfort of our home. And what has also happened is, because of coronavirus, many new opportunities and business cases have come up. So in the next few slides, those I'm going to quickly talk about. In the industry that we serve, whether it be banking or retail or telecom, there has been fundamentally certain business restrictions. There has, of course, been a liquidity constraint. There is a sudden stop it to the access of cash and capital. There's been a reduction in the sales opportunities. Of course, we all know there has been a huge disruption in supply chain. Some of the fundamental ways of doing business have also changed, and there are opportunities to optimize operations and business costs as well. So what it has happened, and I'll request you all to take screenshots here if you would like to, is that each industry has identified certain opportunities where they can apply analytics to better understand how to manage this particular chaos and business environment. So when we talk about banking, stress testing, scenario analysis, risk modeling, those are new topics which have come into play, and fundamentally the industry is asking heavily that how can I use my existing data and use external data, for example data from John Hopkins, and identify which are the high territories with high risks of coronavirus which can impact my business. In insurance, again, there is suddenly a move towards digitization. Insurance in India, for example, is completely agency-led for last 5 to 10 years ago as well. But now, because of lockdown and inability of agents to actually go and meet clients, there has been a sudden shift in the industry from an offline model of customer acquisition to online. And with online comes new challenges. Somewhere down the purchased journey of a customer online, he may stop transacting. So can I retarget that customer and win him back? So new opportunities are coming in insurance. In healthcare, we are all aware, I'm sure all of us are tracking the news. There is, of course, a lot of challenge in terms of resource utilization and optimizing the minimum amount of resources, whether it be humans or it be physical inventory. How do you maximize the usage of that? So those are some of the business use cases which industries are talking. In retail, CPG, manufacturing, fundamentally questions getting asked are, can I anticipate my demand in advance? Can I plan my supply chain in advance so with minimum disruption I'm still able to service customers? I'm sure all of us have experienced this problem during lockdown. Many of the products that we are loyal to were unavailable for us to purchase, and that leads to a little bit of friction and dissatisfaction in the customer's mindset. Not all customers can understand and appreciate the fact that supply chains were disrupted, but as soon as supply chains are revived, how can businesses ensure that the products are available at the grassroots level? This is where analytics helps you. It will help you answer the question, where should I stock my products faster so that it leads to maximum sales? Those are some of the questions which retail, CPG, manufacturing companies are asking. Travel, hospitality, I've already talked about. We are all users of Netflix and Amazon Prime and Hotstar. These companies are also capturing a lot of data about customers and building better recommendation engines and giving you more insights on what to watch next based upon your viewing behavior and your viewing history as well. So a lot of data in terms of customer profiles, in terms of customer usage, in terms of how many times you're using the platform, what time do you access this platform, how many movies, TV shows of what kind and genre are you watching, so that they can make more personalized recommendations. So those are some of the new use cases which are emerging. And the fundamental question we are getting asked from many OTT companies, our over-the-top players, is that once the lockdown removes and people go back to business as usual, how can I ensure that the customer continues to watch my platform? So customer retention is a problem not just for traditional businesses like telecom, but even for new age companies like over-the-top players. I'd like to finish this presentation very quickly by now giving you a perspective on what you can do now to invest in your career in data science. See, there is no one magical golden spoon that you can eat from and get a career ready in data science. It's a lot of hard work and many things to do. The journey begins by first getting the proper theoretical training and cutting edge courses and learning environments to build a foundational knowledge in the field of data science. So definitely get yourself certified and select those electives. They are hard topics, no doubt, but select them so that you have a firm grounding in this practice. The practice without understanding of theory will not serve you far. So that is very much important. Companies like Transorg as well, very quickly. We are also firm believers in spreading the knowledge and awareness. So you can check out our website as well. There's a lot of learning and certifications and education programs that we have also launched. So we'll be happy to share some of those with you. But foremost important is building a career. So you're not building a role for yourself, you're building a career. So you have to understand which industry you want to work in. What industry delights you? Do you want to become a banker? Do you want to join an insurance business? You would like to go into fintech environment or e-commerce? There has to be some understanding of what industry you want to be in. If you want to be in an industry role, many a times students, fresh graduates are not aware of which industry they want to build a career. In that situation, they can come to industry serving companies. They can come to a vendor side of the business. That way, for example, if they join companies like Transorg, you will come to know more about many more industries, and then you can think of a career which industry you would like to specialize in. Ultimately, analytics are nothing but tools and technologies and methods of doing business. But if you don't understand the business, if you don't understand the domain, you will not go far. So you have to build a specialization in one industry or one function. So pick that for the long term. When you have decided and built that clarity that this is the industry, this is the role I want to be the best marketing analytics person in the field of e-commerce, let's say, then identify those domain experts and subject matter experts who are in the top in this field and access them via social media channels like LinkedIn, follow them on Twitter, follow them on webinars, attend these industry events, and seek out mentors so that they can help guide you, shape you, they can talk about industry trends, and they can help you prepare for your future roles as well. You have to build on your resume today. So that comes with maximum experience possible from your internships, from the case studies, go through in external competitions as well, so that you have a firm grounding kind of data which is available in real life, so that when you join your job, the first 90 days, you are not scrambling to understand the basics. You will have at least covered the basics through your internships. So seek out such internships, and there are many platforms today through which you can track these internships. So it's all about networking is what I will say. If you still feel short of knowledge, there is a lot of knowledge available in the broader domain. There are free courses, there are paid courses. Pick courses which have a practical orientation, which provide you some project-based learning experience. They have some trainings so that you have a more improved grounding and learning in the field. So data science as a career is in one line, if I can mention for you, is it's a career which is in a growing trajectory. For the next 10 to 15 years, you will only see growth. Initially, many companies in India were hesitant on applying analytics, but now with the serious adoption of technology, the availability of cloud computing, there is many more opportunities, many new different roles which are available, and the sky is the limit. And this is your ticket to accelerated growth in the corporate world. And many clients I have seen, actually many data scientists who work on the client side, I have seen many of them actually come out of the corporate world and set up their own startups also in this field. So there's a lot of scope to grow through your own startup by joining vendors who are industry serving, as well as by joining an in-house analytics team in the industry itself.